talking about, a predictor of favorability, is linked to the equilibrium constant. They're both two ways of saying the same thing. An equilibrium constant is what's the ratio of products to beginning reactants after an infinite amount of time of the reactions reached equilibrium. What's that product reactant ratio? Call that equilibrium constant. I've been saying that that ratio is also related to the energy drop between the beginning and end of the reaction. So these two terms can actually be calculated one from the other. Delta G is equal to negative 2.3 RT log equilibrium constant, where R is the universal gas constant, T is temperature. You're not going to be doing that kind of calculation for me, don't worry about that, but you do need to know that they're interrelated, that they're both ways of expressing favorability. So let's, if you're following a reaction that's favorable, A is at a higher level than B, so delta G is negative. Let's say you start with a test tube that has nothing but A in it, and there's no B, and you took samples as you went along in time. You start out with 100% A, 0 B, but over time some of the A gets converted to B. After a sufficient amount of time, with or without an enzyme, infinite amount of time, eventually you get here where the product reactant ratio stops changing. We call that equilibrium, of course. And that ratio of the product to the starting material is the equilibrium constant. And it's related to how favorable the products are. The bigger the equilibrium constant, the more negative the delta G. If you had some theoretical case where the product and the reactant were at the same energy level, maybe there would be some traffic back and forth, but even at infinite time, you'd never have more than a 50-50 mix. It would be exactly equal. If the product's a little bit lower energy than A, then at equilibrium after an infinite period of time, you'd have more B than A. If it's way lower energy, then you're going to have way more B than A at equilibrium. So the bigger the drop in energy, the higher the equilibrium constant. That is, the more product at equilibrium.